A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star, where the temperatures on the planet should be okay-ish, and water should stay liquid on its surface. It's not super precise, because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernovae, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come.
Buckle up, fellow space enthusiasts, because we're about to uncover the celestial secrets that have been unveiled this year. From giant stars to organic molecules, this year is going great for astronomers. So let's catch up on all the excitement you might have missed in 2023. First of all, we've discovered some real astral monsters. Imagine looking up at the night sky and seeing stars that are not just big, but absolutely enormous. Scientists have been using a special telescope called the James Webb Space Telescope to explore the early days of the universe. And during their adventure, scientists stumbled upon ancient stars that are 10,000 times bigger than our Sun. Yes, you heard it right, 10,000 times. These giants of the stellar world were some of the very first stars ever to form in the universe, billions of years ago. Imagine a globular cluster as a massive cosmic crew, where each group consists of a whopping 100,000 to 1 million members. These clusters are like giant family gatherings, with all the stars being born around the same time. But what makes these newly discovered monsters so special? Well, their cores, or their central parts, are way hotter than what we see in stars today. Scientists think that this intense heat might be due to a lot of hydrogen burning at really high temperatures. It's like they're having a galactic barbecue party. Something fascinating happens in these globular clusters. The smaller stars crash into the supermassive ones and gain extra energy, like a power-up. But here's the twist. Most of these clusters are now getting old, and the supermassive stars disappeared a long time ago. We can only see hints of their existence in the clusters we observe today. Scientists study them by just the mysterious traces of their grand presence. The discovery of these monster stars is incredibly important for our understanding of the universe. If scientists can gather more evidence to confirm their existence, it would be a major breakthrough. It would help us learn more about globular clusters and how supermassive stars form in general. But that was only the first fascinating discovery of 2023. Although the next one is kinda sad. You know those beautiful rings that make Saturn look so fancy? Well, guess what? They might disappear in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered some fascinating data about the rings. During Cassini's grand finale, when it did some cool maneuvers between Saturn, scientists noticed something surprising. The rings were losing a lot of mass every second. Tons of it. That means this magnificent halo will only stick around for a few 100 million more years, at most. That may seem like a long time for humans, but in the grand scheme of the universe, it's just a blink of an eye. The important thing is that we've learned that huge rings like Saturn's don't last forever. They eventually fade away. Oh, well, at least you and I personally won't catch this moment. Scientists have a fun theory about what will happen when Saturn's rings disappear. They think that the other ice and gas giants in our solar system, like Uranus and Jupiter, might have once had massive rings too. But over time, those rings wore down and became more like the thin, wispy bands of asteroids like what Uranus has now. Saturn's rings are mostly made of ice, but they also have a sprinkling of rocky dust. This dust comes from asteroids and teeny tiny meteoroids crashing into the celestial objects and breaking apart. It's like a snowstorm of icy particles and space debris. The research also revealed that Saturn's rings appeared long after the planet itself formed. They were still forming when dinosaurs roamed the Earth. So, in terms of astronomical age, they're actually quite young, only a few 100 million years old. This discovery has got scientists all excited because it means something dramatic happened in Saturn's past to create this stunning icy disk. But this is a mystery waiting to be solved. Scientists want to figure out what exactly caused the rings to form and why they have such a breathtaking structure. Let's hope they'll figure it out. But moving on to something more optimistic, we have another exciting space news. Recently, scientists have been studying one of the most distant galaxies in the universe, and they found something amazing: organic molecules. The galaxy in question has a long name, SPT 041847. It's over 12 billion light-years away from our little blue planet. Can you even imagine that distance? It's the farthest galaxy ever known, where complex organic molecules have been found. That's why looking at this galaxy is like looking at something from when the universe was just a baby. We have no idea what this galaxy looks like now. The light that has reached us is what it looked like when the universe was only 1.5 billion years old. Imagine being able to see things from so far in the past. So what they found is something with a very complicated name: a polycyclic aromatic hydrocarbon molecule, or simply PAH molecule. You might be wondering, what in the world is that? Well, guess what? You can actually find these molecules right here on our planet. They can be in things like the smoke from car engines or even forest fires. PAH molecules are made up of chains of carbon atoms. And here's the super cool part. They're considered the basic building blocks for life. Imagine that. Life's building blocks. those tiny carbon chains being discovered in a galaxy that's so far away. That's like finding a needle in a haystack. They also found out that gas floating around in that galaxy is filled with heavy elements. That's a big deal because it suggests that many stars have come and gone there, creating all these amazing elements. This means that this galaxy can be potentially rich in many other elements too. This discovery opens up a world of possibilities and raises so many exciting questions. How did these molecules form in a galaxy so distant? And since we're looking into the past, what could have happened to these organic molecules during this time? Could they have evolved into life? We're only scratching the surface of the incredible things waiting to be uncovered. By the way, if it's so far, how did scientists even manage to discover something like that? Well, they had the instrument called the James Webb Space Telescope. This fancy telescope was recently launched and has superpowers when it comes to observing the universe. So when the scientists were studying this faraway galaxy, they had a little problem. The light coming from those distant objects was so faint that it was hard to see or detect. But guess what? They had a brilliant idea to solve this. They used something called gravitational lensing, which is like a special power of nature's magnifying glass. Imagine two galaxies lining up perfectly, just like in a photo shoot. The light from the faraway galaxy, the background one, travels towards us. But on its journey, it passes through the foreground galaxy, which is like a giant space lens. And guess what? The foreground galaxy's gravity bends the light, just like a magnifying glass, making it bigger and brighter. It's like having a cosmic zoom lens for our telescopes. This bending of light creates a super cool shape called an Einstein ring. It's like a halo, or a ring of light surrounding the foreground galaxy, basically a nature's way of showing off its magical powers. With gravitational lensing and these beautiful Einstein rings, scientists can see distant objects more clearly and learn amazing things about the universe. And thanks to all that, they managed to uncover the hidden chemical interactions from the early galaxies. Isn't that incredible? The scientists are beyond excited about this discovery. They never expected to find such complex organic molecules in a galaxy that's incredibly distant. Who knows? Maybe this is just the beginning of a thrilling cosmic journey. So, keep your eyes on the stars, fellow space explorers. The universe is full of surprises, and who knows what other mind-blowing discoveries await us out there. Let's hope we'll learn even more in the future.
Ah, space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it emits other wavelengths too, all these colors mix together and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas, mostly made of hydrogen and helium, and it works more like a gigantic nuclear reactor. constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy. That's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans, a spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So, technically, you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope, you won't turn into a popsicle right away. It's gonna take a bit longer than that because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out, so all those epic space battles and galactic explosions would be completely silent. Yet there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free-falling around the planet. And let's be real, Hollywood's version of space travel is not factual. Sure, orbits are a thing, but different altitudes mean different speeds. So moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. the solar system stays in place. Lie! It's zooming through space at a speed of 140 miles per second, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes us 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket, because that would be one astronomical fine. Eh? Without the sun, planets would be pretty chilly. We're talking about temperatures as low as -455 degrees Fahrenheit. Brr! But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things like the planet's size and reflectivity also come into play. So Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe. And there's still so much we have yet to discover. Who knows? Maybe one day we'll really discover little green people out there. Or maybe we'll find out something even more incredible. Until then, we'll just have to keep dreaming and exploring. There, you got 14 things on our list. Do you have any other space myths to debunk?
Scientists were looking at a list of gas clouds when they saw something strange. 5 groups of blue stars that are not quite a galaxy and not a known type of star cluster either. These groups of stars are called blue blobs, and they're located in the Virgo galaxy cluster. Now, the big question is, how did these blue blobs form if they don't have any nearby parent galaxy where they could form? Scientists realize there are some heavy metals present in these blobs. Generally, when stars are born, they create heavy elements called metals. These metals are essential building blocks for new stars. In big galaxies, many stars form over time, and as a result, more metals get created too. These heavy metals in the blue blobs were a clue that the stars in these blobs were formed from gas that was stripped from a larger galaxy. Think of it as a piñata. The candy is the gas, and the piñata is this bigger galaxy. The blue blobs are the leftover candy that was scattered around. Wow. Didn't expect to get hungry while talking about stars. How did the gas get stripped away from the bigger galaxy anyway? There are 2 ways. When galaxies pass by each other, their gravitational attraction can cause gas to be pulled away from one galaxy and into the other. This is called tidal stripping, and it's the first way these blobs can happen. It's like when 2 magnets attract and pull metal objects toward each other. Another way is ram pressure. This happens when a galaxy moves through a cluster of hot gas at a pretty high speed. The gas in the cluster can push against the gas in the galaxy and force it out back, similar to a car pushing air out of the way as it drives, and you lose your hat in a strong wind. As time goes by, these stars and the blue blobs will keep on moving apart. Eventually, they will form smaller clusters. Have you ever seen pictures of Earth taken from space? They're amazing. But have you seen the one with 2 blue blobs of light? The first blob of light you see here is a large lightning strike in the Gulf of Thailand. It's rare to see lightning from space because of all the clouds, but this one was so huge it lit up the clouds around it like some kind of a brilliant ring. How cool is that? The second blue blob of light is a bit different. We're looking at the reflection of the moon's light on our home planet. The moon actually reflects the light coming from the sun onto the Earth. And when that light goes through the Earth's atmosphere, it creates a big blue blob with a fuzzy outline. It's like a shiny blue hat our planet is wearing. It's similar to the reason why the sky is blue during the day. When sunlight enters Earth's atmosphere, gases and particles in the air scatter it in all directions. Blue light has the shortest and smallest waves, so it gets scattered the most. And that's why we get to enjoy a beautiful view of a clear blue sky. The same thing actually happens to the light coming from the moon. When it reflects off the Earth and goes through the atmosphere, the blue light waves get scattered the most, making the moon appear blue in the photo. Speaking of unusual stars, there's one in the Centaurus constellation called Lucy. It looks like a tiny white dwarf, but it's actually very dense. There's a mass of the entire sun squeezed into an object only a third of the size of our home planet. That's like stuffing a whole watermelon into a golf ball. Lucy is also incredibly cool. Its core temperature is almost 12,000 degrees Fahrenheit. This may sound hot at first, but for comparison, our sun is about 27 million degrees Fahrenheit. And the best part that makes Lucy so special is the diamond at its heart. Its carbon core has crystallized into a massive diamond that's 10 billion trillion carats in size. It's hard to even imagine how big it is. Scientists found out about this awesome diamond by listening to the star's vibrations, which is like a star's heartbeat. And after they discovered Lucy, scientists found some other stars with crystallized cores and massive diamonds the size of Earth, too. Our universe is like a giant jewelry store. Most of the astronomers from the northern hemisphere are familiar with the star named Vega. First, it's brighter than expected. But if you could take a look at it from a different angle, you'd see this star is actually squashed. It has a specific oblong shape because it rotates at a high rate. It spins once every 12.5 hours, which throws the material out around its equator. This material then cools and darkens, and forms a dark, mysterious halo around Vega. When stars reach the end of their lives, they often explode in a dazzling supernova, getting brighter and brighter before they finally fade away. But one supernova, IPF-14Ls, decided not to obey the rules. It started to fade away like most other stars, but then, when everyone expected it to be gone, it suddenly came back to life and brightened up again. And not just once. It kept fading and brightening at least 5 times in a row. Scientists were so surprised to see this. When they measured the light from the supernova, they found it was evolving 10 times slower than other stars. It was aging way more slowly, too. When it looked 60 days old, it was actually 600 days old. It could be even older, because scientists had recorded another supernova in the same spot almost 70 years ago. There are some theories as to how it could have happened. Maybe the supernova was bumping into some surrounding material and then making it glow. Or maybe it was a giant star that was shedding material all the time to prevent, or at least postpone, its own collapse. At first, it may seem like you're looking at a simple variable star here, my Camelopardalis. But when astronomers looked more closely, they realized it was a pair of stars. The two stars are moving around each other at really high speeds, and their atmospheres are starting to mix because they are so close. People believe this example is the start of a union between two stars. In the end, the two celestial bodies, which already weigh 32 and 38 solar masses each, will join together to make a gigantic one with more than 60 solar masses. Scientists have thought for a long time that this is how super big stars form. They've never really seen it happen. The universe is 13.8 billion years old. And from what we can see, one mysterious star, HD 11402883, could be 14.4 billion years old. Something's not right here. This star has all the chemical signs of a second-generation star, which is a star that formed from gas and dust after the first generation of stars exploded. This star, sometimes called Methuselah's star, is 190 light-years away. Its brightness, distance, and composition help us figure out how old it is. At least 13.2 billion years old. While the age of 14.4 billion years is probably put there as a potential range. Even if it's younger than the universe, or is it? It's still by far the oldest star near us. Let's not forget the one with a tail either. It's called Mira. Sometimes it's bright, and other times it's faint, making it a bit of a tricky one to spot in its constellation. Sometimes it's one of the brightest stars up there, while other times it is one of the fainter ones in its constellation. It's the system with two stars, a red giant, and a white dwarf. The red giant used to be like our own sun, but now, as it's closer to its end, it's shedding its outer layers into space. And Mira has a comet-like tail too. As the red giant sheds its outer layers, it creates a stream of gas and dust that follows the stars as they move through space.
So, what comes to your mind when you hear the words green monster? The Hulk? Shrek? Probably. But definitely not a young supernova in the Milky Way galaxy. Oh, and if you have forgotten what our home galaxy looks like, here, have a look. So anyway, is that supernova indeed green and, scary? Not really. But let's start from the very beginning. Cassiopeia A, aka Cass A, is the remnants of a stellar explosion astronomers spotted in the sky 340 years ago. This supernova is 11,000 light-years away from us in the constellation Cassiopeia, and its remains span about 10 light-years. Recently, scientists have managed to capture the sharpest image of these leftovers yet, all thanks to the James Webb Space Telescope, the largest optical telescope in space. The image is full of bright colors, brilliant green, orange, and pink. Maybe if you printed it out, it would make a great painting for your living room. Just like this canvas. Each hue represents a different wavelength of infrared light, which is normally invisible to the human eye. The image can help astronomers figure out what happened to the poor star before its demise. Cass A is the youngest known remnant of a massive star that once exploded in our galaxy. On its exterior, at the top and left, you can see curtains of material that seem red and orange because of the emission of warm dust. That's where the ejected material from the exploded star collides with the surrounding gas and dust. Inside this outer shell, there are chunks of bright pink bubble-shaped material that form clumps and knots. It comes from the star itself. This material is shining because of the mix of heavy elements like neon, argon, and oxygen. Astronomers have spotted some dust emissions in that region too, but they haven't located the sources of these emissions yet. There's also a prominent green loop extending across the right side of the supernova's central cavity. And if you look closely, you'll notice that a big region of Cass A is pockmarked with something that looks like small bubbles, which makes the thing even more complex and hard to understand. The first X-rays from Cass A appeared in the 60s, but light from the supernova probably reached Earth in the 1600s. Unfortunately, there are no confirmed written observations of the supernova from those times. It must have looked like an extremely bright star, and historians still doubt whether any observers noticed it. Oh, and I bet you've been wondering about the nickname, right? This space phenomenon was called the Green Monster in honor of Fenway Park in Boston. Its large green left-field wall has the same name. One of the main questions Cass A might help us answer is, where does all that cosmic dust come from? Astronomers have discovered that even very young galaxies at the early stages of their lives are filled with massive amounts of dust. So, does the universe need vacuum cleaning, or is the problem more complicated? One of the crucial components in the appearance of this dust seems to be supernovae. They spew truly terrifying amounts of heavy elements, which are basically building blocks of dust across the cosmos. So let's try to figure out what these supernovae are and how they occur. Good old stars keep their spherical shape because their gigantic mass creates a powerful gravitational field that pulls gas toward the center, and at the same time, their cores produce enough energy to prevent gas from gathering too close to the center. All this creates a nice balance and a beautiful ball-like shape. But once a star becomes too old and massive, about 4 to 8 times as big as our Sun, it doesn't have any more fuel left. That's why all the reactions in its core stop. The star's outer layers instantly try to collapse inward, but they bounce off the core, which remains incredibly dense. That's when everything but the star's core blasts out all over the universe in a bright supernova explosion. Now, as you may know, our solar system itself can be a pretty scorching place. For example, the temperature of Earth's core almost reaches a whopping 10,800 degrees Fahrenheit, which is about as hot as the temperature on the surface of the Sun. As for the Sun's super-hot center, it's heated up to 27 million degrees Fahrenheit. Okay, that's hot. But if we talk about the universe, such temperatures are nowhere near hot in comparison with a supernova. As you now know, it's the very last stage of a star's life, which ends in a gigantic explosion. This explosion is one of the largest in space, and it unleashes enormous amounts of energy. Therefore, the temperature at the core of a supernova is an incredible 6,000 times higher than that of the Sun's core. And it means it can reach several billion degrees Fahrenheit within microseconds, which is almost impossible to imagine. After that, atoms get crammed together so infinitely closely that the squeezed core recoils and a star explodes, creating a superheated shockwave. Anyway, let's get back to our Cass A. By studying it with the help of the James Webb Telescope, astronomers hope to get a better understanding of its dust content. This, in turn, will help them figure out where the building blocks of stars, planets, satellites, and us humans come from. Experts can locate regions with different gas composition and look at the types of dust that form there. Oh, by the way, if you're interested in space too, but don't have your access to the James Webb Telescope, you can get yourself a telescope of your own and enjoy amazing views. Supernovae, as the one which created Cass A, are very important for life as we know it. They spread such elements as, for example, calcium that we have in our bones, or iron our blood contains, literally seeding new stars and planets. You, my friend, are made from star stuff. Supernovae don't always mean the end of stars. Even though a star loses its outer layer, it might still survive the explosion. Then it either becomes a black hole or a new kind of star. See for yourself. Even without the outer layers, a star's core keeps collapsing. At one moment, the pressure inside becomes so high that electrons and protons virtually melt into each other and form neutrons. The result of this crazy fusion is a neutron star, whose mass consists of 90% of neutrons. It means that the thing just can't get squashed any tighter. Then, energy starts to leave the fading star, transforming it into a neutron star. And the amount of this energy is so great that it can be compared with the combined light emitted by all the stars in the observable universe. Energy is leaving the star in the form of neutrinos, subatomic particles that are similar to electrons but with no electric charge and a very small mass. And during a supernova explosion, the star emits almost 10 times more neutrinos than the number of protons, electrons, and neutrons in the Sun. No wonder that in such conditions, something truly scary gets born. A neutron star, which is basically a monster nucleus, the central part of an atom, is relatively small. Even though scientists don't know for sure how big neutron stars are, they suppose that these space bodies shouldn't be bigger than 12 miles across. For comparison, our Sun is almost 865,000 miles across, which is 109 Earths put side to side. But even with such a modest size, any neutron star will be at least 1.5 times heavier than the Sun. Think about this. If you scoop just a teaspoon of neutron star insides, this stuff would weigh no less than 1 billion tons. That's very dense. So dense that the next stop is the black hole itself. Well, what can I say? Space is an endless source of mystery and inspiration for me. I'm even considering adding some space vibes to my home, and I know just the thing to do it. Hey, don't thank me.
Astronomers have been asking one question for decades. Is space really as black as we think it is? Well, NASA's New Horizons space mission might have just given us the answer. After exploring Pluto, the spacecraft kept going and is now billions of miles away from Earth. This means it's far from all the light pollution we get from sources like the sun and dust particles around our planet. Scientists used the spacecraft's simple camera to take images of what looked like incredibly boring blank space, free of bright stars or anything else that could scatter light back into the camera. They then processed these images to remove all known sources of visible light. Once they'd removed the light from stars, plus scattered light from the Milky Way, they were left with light coming in from beyond our own galaxy. But here's the surprising part. They found that there was still plenty of unexplained light. In fact, it was about equal to all the light coming in from the known galaxies. That means there's just as much light outside of galaxies as inside them. So, where does all this light come from? Well, it could be coming from sources we haven't yet discovered, like small, faint dwarf galaxies or unknown phenomena out in the universe. Or it could be associated with dark matter, which is still a mystery to scientists. With this groundbreaking research, we can say that space isn't as dark as we know it. What if we take all the light from the stars and galaxies out there and throw in some gas and dust clouds? What color do we get? Beige. This leads us to another question. Do we still need the sun if our space is colorful? And the short answer is, yes, we do. The colors of space are a result of the interactions of light with different celestial objects, such as stars, galaxies, and gas clouds. While these colors are fascinating to observe, they do not provide the energy life on Earth needs to survive. There you go. Don't expect to see the color of the sky in space.
These eerie objects are called quasars. They're some of the brightest and most powerful objects in the universe. They lurk in the depths of space, consuming entire galaxies with their insatiable hunger. But what are quasars? Where do they come from? And most importantly, are they dangerous to us? Picture a supermassive black hole, a cosmic monster so massive that it can swallow entire stars and bend the fabric of time. Usually, there's such a black hole in the center of every galaxy. That includes our own Milky Way galaxy. Ours is named Sagittarius A star. Sounds like the name of a hipster coffee shop, but in reality, it's a terrifying celestial body, which is 4 million times heavier than our Sun. You could even see it online. For the first time, we took a photo of this black hole in May 2022. But don't worry. Even though it's supermassive, it's not going to swallow us up anytime soon. This black hole is relatively small, and is too tiny to eat an entire galaxy. So it's more like a cosmic vacuum cleaner that sucks up stars or gas that gets too close. But there are black holes in the centers of galaxies that are way heavier and more dangerous than ours. They can weigh millions or even billions of times more than our own Sun. Now, imagine one of these monsters. Usually they're surrounded by a swirling, glowing disk of gas and dust, like water swirling down a drain. It's called an accretion disk, and it's where the magic of quasars happens. As material from the accretion disk falls toward the center, it heats up to millions of degrees, releasing vast amounts of energy in the form of radiation. And this radiation is what we observe as a quasar. So basically, the more material a black hole can consume from its surroundings, the brighter its quasar will be. This is what makes them so bright and powerful, shining like beacons in the night sky. And just imagine, some black holes can actually make entire galaxies their meal. Now, combine their ravenous appetite with some intense radiation, and you'll get a truly awe-inspiring display of cosmic power. No wonder we can see them, even though they're some of the most distant objects in the universe. Quasars were discovered in the late 1950s by accident. Astronomers were just chilling and looking at the sky when suddenly they stumbled upon something strange. Radio signals that had no visible source. By 1960, hundreds of these strange objects had been found. Astronomers named them quasars, short for quasi-stellar radio source. These objects were small and far away, but their energy output was immense and difficult to explain. Some thought that these were new types of stars. Others even proposed wild things, like quasars being made of antimatter or being the end of a wormhole. But all these theories were discarded. A scientist named Martin Schmidt was the first one to get to the truth. However, many astronomers didn't believe him. Schmidt had to do a lot of extra work and gather lots of evidence to prove his theory. And finally, he prevailed. And that's how we discovered quasars. Don't you love the scientific method? And since then, astronomers have been captivated by these objects. Why? Because they have some pretty eerie qualities. You could call them quasi-quasars. For example, they kind of defy the laws of physics. They emit jets of particles that travel at speeds close to the speed of light. These particles move so fast that they can even distort the very fabric of space and time. But sometimes, they also help us confirm the laws of physics. Now imagine driving a car. As you drive, objects in the rear window start to appear smaller and smaller until they disappear from view entirely. That's exactly what happens with quasars, except they're moving away from us at incredibly fast speeds, up to 90% the speed of light. Wonder why they're trying so hard to sprint away from us. But in any case, this helps us confirm that the universe does expand for real. Another eerie thing about quasars is that they're incredibly old. Some even date back to the time when galaxies were forming, or to the birth of our universe. Additionally, quasars are some of the most distant objects that we can observe in the universe. Some of them are located billions of light years away from us. This means that when we observe a quasar, we're actually seeing light that was emitted billions of years ago, when the Earth was much younger and different than it is today. And that's why they work like cosmic time capsules. Studying them gives us a glimpse into the distant past. You see, galaxies are like giant cities, with stars and planets serving as the inhabitants. But just like cities evolve over time, galaxies also undergo changes as they age. And that's where quasars come in. They're like the urban planners of the universe. They shape the galaxies through their powerful gravitational influence. By eating galaxies and releasing intense radiation, they can trigger star formation and shape the structure of the galaxy itself. It's like the cosmic equivalent of a master chef, or a leaf blower, you pick. For example, let's take galaxy mergers. Here are two massive entities coming together, swirling and spinning around each other. As they get closer and closer, their gravitational pull becomes stronger, and they start to merge into a new, bigger galaxy. It's a beautiful and dramatic process, one that can take millions of years to complete. But all this doesn't go without consequences. The gas and dust within the galaxies collide, creating massive shock waves that trigger the birth of new stars and even supermassive black holes. And this is where the quasars come into play. Some quasars may be born during these galactic get-togethers, and thanks to this, they help us study the effects of this process and the evolution of galaxies over time. But it's not all serious science and no fun. For example, how about gravitational lensing? Now, that's something straight out of a sci-fi movie. It happens when the gravity of a massive object, like a quasar, bends the path of light from a more distant object, like a galaxy, behind it. It's like having a really big magnifying glass in space. When you combine a quasar with gravitational lensing, you get some seriously awesome cosmic eye candy. The result is kind of like a funhouse mirror, where objects appear warped and twisted in strange and mesmerizing ways. Gravitational lensing isn't just for show. It's also a powerful tool for astronomers to study the distribution of dark matter and the structure of the universe. And that's not all. Some scientists have proposed that quasars could help us build the map of the universe. They can work like giant neon road signs. Turn left at the quasar and you'll reach your destination. They're like lighthouses that help us navigate through space. By analyzing the light from different quasars, astronomers can determine the distances between them and create a 3D map of the universe. And the best part? Quasars are located throughout the entire universe. That's why this cosmic map can give us a comprehensive view of the universe on a scale that was previously unimaginable. Who knew that a giant galaxy eater could be so useful? There's still a lot we don't know about these mysterious objects. In 2007, a team of astronomers made an astonishing discovery: the first true binary quasar. Basically, this means two huge quasars spiraling around each other. What's more, they were hiding in plain sight. For years, scientists had known about this radio source, but had never realized that it actually comes from one lovely couple. The astronomers also estimated that this pair may have a mass of about 100 billion suns. They're super distant, though, at an astounding 12 billion light-years away from our blue planet. Overall, quasars are a fascinating and complex phenomenon that continues to baffle and intrigue scientists. They may be cosmic galaxy eaters, but they're also playing a critical role in the formation and evolution of the universe. And who knows, maybe one day they'll become one of the keys to unlocking the mysteries of our universe. Oh, you quasi-quasars!
You get the last instructions from the team and get into your spaceship. It's the first spacecraft made on Earth that can move at a speed close to the speed of light. Your task is to visit the most unusual and terrifying places in space and send scientists detailed information about them. And so, your journey begins. Your spacecraft is accelerating, and you dash past the moon. In the distance, you see a small reddish planet. It's Mars. And look at that spectacular giant surrounded by a set of rings. That's Saturn. You wish you could have more time to explore this gas giant, but you have to hurry. You pass by beautiful stars. Some of them are luminous, others have a reddish hue, and some seem to be dimming. That's Sirius, the brightest star in the night sky on Earth. It's about 8.6 light years away from us, but you're traveling fast, and soon you see Polaris, aka the North Star, which is way further, 431 light years away. Sometimes you manage to spot tiny dots circling these stars. Those are planets. And then, suddenly, you see nothing. At first, you're horrified. Something has gone wrong, and you've accidentally entered a black hole? Has your equipment malfunctioned? Because it seems that at a distance of 700 million light years away from Earth, there's a hole. A blank void with no galaxies, stars, planets, or asteroids. You can't see anything. The void is a roughly spherical region of about 330 million light years across. Our home Milky Way galaxy could fit in there billions of times over. And then it dawns on you. What you're looking at is the mysterious Boötes void. It lies about 700 million light years away from Earth in the constellation of Boötes, the herdsman driving the plow around the North Pole. At first, this void was called the Great Nothing, but later it was given its current name. Now we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are ginormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light years wide. The Boötes void is one of the most massive ones. It's even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, all the matter in the universe was packed together quite tightly. Astronomers even think it was something like a uniform soup. But pretty soon, random quantum fluctuations started distributing this matter. Some areas became denser. As a result, their gravitational pull became stronger, and they began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. After staring at nothingness for some time, you decide to explore other space objects and start the engine of your spacecraft again. There's one kind of space formation you've been looking forward to seeing: nebulas. 5,000 light years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and got its name for a reason. Its double shell formation looks like a person's face hidden in a padded hood of a winter jacket. But in reality, this parka is a disk of material with a ring of comet-shaped objects. And the tails of these objects stream away from the star at the center of the Eskimo Nebula. The bizarre orange streaks in the outer part of the cloud stretch light years away in all directions. As for the Eskimo's face, even though it resembles a ball of twine, in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Your next destination is the Ring Nebula. At first sight, it's a giant cloud of dust and gas surrounding an old, almost extinguished star, which does look like a ring. But astronomers say the nebula isn't a bagel, it's a jelly-filled donut. The deep space colorful object more than 2,000 light-years away from Earth is actually a ring that wraps around a blue, ball-shaped structure. Each end of the structure sticks out of the ring's opposite sides. Now you can head to a place called the Pillars of Creation. You find it more than 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old, space babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called Pillars of Creation, an active star-forming region. And since you've already visited a star-forming region, why don't you drop by a living fossil galaxy? For example, DG-SAT-1. It's as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It can mean that DG-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. The next stop on your space sightseeing tour is the Black Widow Pulsar. Just like its spider namesake, this rotating neutron star is munching on its partner, a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. Oh, look at this! That's a stellar nursery in the constellation of Centaurus. But even though this place might be called nursery, it's anything but peaceful or safe. This region, made up of hydrogen and newborn stars, is located in a nebula in the constellation of Centaurus, around 6,500 light-years away from Earth. The intense energy these baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful that it's eating away dark clouds of dust, and they're disappearing like lumps of butter on a hot frying pan. You're continuing your journey when you see something absolutely amazing, a cloud of water floating in space. To be more precise, it's a cloud of water vapor surrounding a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. Earth's magnetic field hides a fascinating story. It turns out that it's getting weaker day by day. In fact, it's been doing so for the last 3,000 years. And if this trend continues, we could be in for some trouble within a millennium. What's the big deal? Well, picture this. Magnetic north becomes south, and vice versa. Pretty wild, right? When this happens, our planet's protective magnetic shield might weaken, allowing more cosmic rays to hit us. These high-energy particles from the universe can cause electronic malfunctions in our satellites and produce elements that could be harmful to us. The last time a polarity reversal occurred was between 772,000 and 774,000 years ago. Thankfully, humanity has some pretty smart people on the case who are investigating the history of Earth's magnetic field. They take cores of sediments from the seafloor and study the magnetization of fossils to figure out when these reversals occurred in the past and when they might happen again. Another group of researchers is studying the South Atlantic Anomaly, SAA, a vast region of Earth's magnetic field that is about 3 times weaker than the field at the poles. Using data from multiple satellites, they are trying to figure out what's causing the SAA and how it might change in the future. This could give us a glimpse into how a weakened magnetic field can affect our satellites and our planet. Sure, our generation won't be here to witness these changes, but it does make you wonder what that planet might look like upside down. Magnetically, that is. NASA's astronomers have also announced that in 4 billion years, the Milky Way galaxy is going to get a major glow-up. After a cosmic collision that will shake things up. I'm not talking about a small fender bender here. I'm talking about a titanic collision with our neighboring Andromeda galaxy. Humanity will have to hold on to its space helmet for this one, because the sun might get flung into a new region of the galaxy. However, our Earth and solar system probably won't be seriously affected. Sounds difficult to believe, so how come? NASA's Hubble Space Telescope did some hardcore measurements of Andromeda's motion. Although the galaxies will plow into each other, the stars inside each galaxy are so far apart that they won't collide with other stars during the encounter. However, the stars will be thrown into different orbits around their new galactic centers. According to simulations, our solar system will probably be tossed much farther from the galactic core than it is today. Set your telescopes aside. You don't need to start counting down the years. This event is likely scheduled in about 4 billion years, so chances for us to witness it are 0. Saturn is losing its rings. Thankfully, we won't be here to witness this sad event either. Apparently, the rings are being pulled into Saturn as a dusty rain of ice particles, all under the influence of Saturn's magnetic field. According to NASA's research, the ring rain is draining an amount of water products that could fill an Olympic-sized swimming pool from Saturn's rings every half an hour. The entire ring system will likely be gone in 300 million years. Scientists believe we should consider ourselves lucky to witness Saturn's ring system at all, as it seems to be in the middle of its lifetime. But if you think about it that way, that rings around planets are all temporary, there's a chance we've just missed out on the giant ring system of Jupiter, or those of Uranus and Neptune. These planets have only thin ringlets around them these days. Scientists have long debated whether Saturn was formed together with its rings or if the planet acquired them later in life. The new research favors the second scenario, indicating that they are unlikely to be older than 100 million years, while Saturn itself is around 4.5 billion years old. What caused the rings to appear in the first place? Well, there are a few theories. One of them suggests the rings could have formed when small, icy moons in orbit around Saturn collided. Perhaps their own orbits were messed up by a gravitational tug from a passing asteroid or comet. Who knows what humans might end up looking like in the future? It's unlikely we'll see any major changes in our lifetime. But let's take a journey to the future and ponder what we might evolve into. Will we become cyborgs with all sorts of cool machine implants? Or maybe we'll become a hybrid species of biological and artificial beings. To understand our future evolution, we gotta take a peek at our past. 1 million years ago, Homo sapiens didn't even exist. There were a few other similar species though, like the Neanderthal. Fast forward to today, and humans have become taller and sturdier. Maybe in the future we'll become smaller to conserve energy, as it's predicted that our planet will get more crowded. Speaking of crowded planets, living in these new conditions means we have to adapt, and fast. We're constantly interacting with lots of people, and remembering names is becoming a crucial skill. Luckily, technology might help us out with brain implants that will improve our memory. In the future, we might also have more noticeable technologies as part of our appearance. Imagine having an artificial eye with a camera that can read different frequencies of light. While predicting 1 million years into the future is pure speculation, we can use bioinformatics to make some predictions about the immediate future. Demographic trends suggest that urban areas will become more genetically diverse, while rural areas will become less diverse. And what about space? If we end up colonizing Mars, our bodies could change due to lower gravity. Maybe we'll have longer arms and legs, or even insulating body hair like our Neanderthal cousins. In the future, our moon is also going to witness some dramatic changes. We'll miss these ones too. In about 5 billion years, things are going to get really interesting in this corner of the universe. For now, the sun is chilling in its main sequence phase, just burning hydrogen like nobody's business. In the future, during the red giant phase, the sun is gonna puff up like a balloon until its atmosphere reaches out and engulfs our beloved Earth and Moon. Our natural satellite, which is already moving away from Earth, is gonna get warped around the sun's influence. Its orbit will get all wonky, and it'll end up closer to Earth during the new moon phase than during the full moon. And that's not even the worst part. If left alone, the moon would keep on moving away from Earth until it'll need almost 50 days to orbit us. As the sun continues with its own journey, its atmosphere will drag on the moon and cause its orbit to decay. Eventually, the moon will get torn apart into a stunning ring of debris circling Earth. We're talking about all its mountains, craters, and even the footprints and flags we left there, all scattered throughout the debris field. There's a chance the sun will shed enough mass to spare Earth and the moon from total annihilation. Or if we're really lucky, the sun will lose 20% of its mass and we'll be safe and sound. It's all just theory right now. We haven't seen a red giant star during this phase. The universe itself might go completely dark one day too. Scientists can't predict it with absolute certainty, but they can make some educated guesses. Right now, our universe is 13.77 billion years old, and it's still churning out new stars left and right. It's said that eventually, after about 1 trillion years, the last star will be born. That final star will be a little guy, a red dwarf, just a fraction the size of our sun. These stars are champs at living long lives, slowly sipping on hydrogen to keep their fusion reactions going. But even they can't last forever. Fast forward about 100 trillion years, and the last light will go out. The universe will be dark and lonely, but thankfully, we won't be here to watch it all fade away.
You know, it's hard not to wonder if there's another form of life out there in the universe when you look up at the night sky. There's this thing called the Fermi Paradox. It basically says this: if civilizations that might live somewhere out there in the universe are so common, why haven't we found any signs of them? We've looked really hard, but we haven't stumbled over any proof that there are other forms of life somewhere in space. And we suspect there could be many civilizations, because scientists have calculated there are possibly billions of habitable planets in our galaxy alone. So, it would seem reasonable to assume that some of these planets could have developed intelligent life, possibly even civilizations that are more advanced than ours. So, the Fermi Paradox basically says, hey, where's the party? How come we weren't invited? And one of the potential answers to why we haven't found any other form of life in the universe is something called the Great Filter Theory. This theory appeared in the 1990s, and it says there's a big obstacle or challenge that prevents life from being widespread in the universe. It's called the Great Filter because it suggests that there is a filter that most, if not all, civilizations must pass through in order to become really cool and advanced, like the ones from science fiction movies. But so far, there are no signs of other civilizations like that, or even some real evidence of any form of life. Maybe it's really hard to evolve into a complex life form, or maybe it's really hard to develop the technology to travel through space. Either way, it sounds like a tricky obstacle all intelligent civilizations may face, the one that doesn't allow them to make any progress beyond a certain point. It means they might have come to a certain level of development and then something happened that destroyed them, like an asteroid impact or an environmental disaster. Or they could cause their own demise, and bam, everything they've achieved is gone. So the Great Filter suggests there's some kind of obstacle that stops intelligent civilizations from becoming advanced enough to make contact with other civilizations or colonize other planets. This theory presents two interesting scenarios. The first one says that the filter lies in our past and that we have already overcome it. This would mean we have passed the hardest phase and the test in general. Well, woohoo! But it would also mean that intelligent life is relatively rare in the universe and that we may be the only advanced civilization that exists at the moment. So, the universe could really be relatively empty when it comes to intelligent life. That means the chances that we'll make some friends from other planets and visit them in our super cool spaceships are low. Well, that's sad. But the second scenario is a lot worse. It states that the filter could actually lie in our future. We haven't faced this mysterious and pretty advanced test yet. That means there's still a chance for us to fail. If the filter really does lie in our future, it may mean there are many intelligent civilizations out there, but they're all struggling to overcome the same obstacles that we could face sooner than we think. They may be trying to pass these tests, stay alive, and send us a message that we're not alone and that they would like to visit us too. One of the things the Great Filter theory talks about is the development of artificial intelligence, or AI. As AI technologies become more advanced, it's possible that it could pose a threat to humanity, or lead to unwanted consequences if we're not careful enough with it. There's still hope, though. Not everything is so dark and gloomy. Maybe some civilizations have already passed the Great Filter and are out there in the universe, and they'll manage to send us a message. Maybe a life form that is still not bigger than bacteria is somewhere out there, and they haven't come to the level where they're developed enough to communicate with us. Or maybe we'll be the ones to pass the test and send a message to others one day. Well, either way, scientists are not giving up. They will keep looking for traces of life all around us in space, especially in our solar system. And some of their discoveries tell us we may not need to look beyond our own neighborhood to find signs of life. First, there's Enceladus, a small moon that circles around Saturn. In the beginning, researchers of geysers of frozen water that were spewed from cracks in the southern part of Enceladus. One of the most likely explanations is that there are oceans of liquid water lying under the frozen surface. They remain warm because of the gravitational forces between Enceladus and other Saturn's moons. Water is a key element for development of life, so you never know. Also, scientists have discovered the presence of phosphorus on Enceladus, which is another essential element for life to appear. It's one of the 6 basic building blocks of life, and it plays a very important role in many biological processes, such as cell membrane formation, energy transfer, and such. They believe the phosphorus probably comes from the moon's rocky core and is transported to the ocean through hydrothermal vents. Moving to the next potential location that could contain some form of life, Titan, Enceladus' big brother. It's the only moon in our solar system that has clouds and a dense atmosphere that you'd normally find on planets. And it's the only known place in our solar system, except for Earth of course, that has liquid lakes, filled with methane and ethane, liquid natural gas, but still. Titan is a world that resembles Earth the most. Scientists even believe that conditions there are similar to those Earth had in its early years. Our home planet is closer to the Sun, though, so it's always been warmer. Titan might also have an underground ocean of liquid water beneath its surface. Now, we can't miss Mars when we're talking about the possibilities of life in space. One of the main pieces of evidence is methane scientists found on the red planet. Methane is a gas that can be produced by living organisms, think cows, so it might be an important sign. They also have found organic compounds on the surface of Mars, which are the building blocks of life. Another promising discovery on Mars is liquid water. There could be a lake located under a polar ice cap, and scientists believe it could even contain microbial life. Europa is one of the moons that orbits Jupiter. It potentially has plenty of water, too. There could be a salty ocean under its nearly 10 miles thick crust with more water than all of Earth's oceans contained together. There's likely a rocky seafloor at the bottom of this mysterious ocean. The interaction between the rocks and the ocean could create chemical nutrients that organisms, if there are any, need to survive. Europa's secret ocean probably has hydrothermal vents too. Those are basically areas where hot water and minerals are released from the seafloor. These vents support a variety of life forms on Earth, so it's exciting to know that there's a possibility that similar life forms could exist on Europa as well. The problem could be radiation coming from Jupiter. It's really strong, and as such, it can be really harmful to any potential life forms there. Any life on Europa would need to have some sort of shield so it could survive such intense radiation. Let's also check the second biggest Jupiter's moon, Callisto. It has many craters, but it's still one of the most geological inactive bodies in the solar system, with no active volcanoes or tectonic activity. That's why its surface is mostly the same as it was at the time the moon formed, which is why it gives us a unique window into the early history of the solar system. And, you guessed it right, Callisto also has a subsurface ocean that could potentially hold life. Fun to think about, eh?
Two pictures are rapidly changing in front of your eyes: our huge planet and a black void. The picture of Earth is getting smaller by the second. You're flying away from the spaceship into an endless vacuum and don't know what to do next. The International Space Station flies 250 miles above Earth's surface. A spacewalk is routine for astronauts who work there. Astronauts have spent more than 11,000 hours in the black abyss to this day. Fortunately, during all this time, no one has ever flown away into outer space without coming back, as we've seen in the movies. But unfortunately, astronauts face other, no less terrible, dangers during spacewalks. One such accident happened in 1966. Eugene Cernan put on a jetpack and went into outer space to carry out some repair work. The jetpack, which helps an astronaut control flight in zero gravity, heated up a lot. Eugene put on special protective pants made of metal to protect himself from this heat. The pants protection didn't work when he went into outer space. Instead of directing the heat away from his body, the pants began to heat up. The suit was heavy and uncomfortable, like a knight's armor. It rubbed his skin and restricted movement. Working in zero gravity is physically very hard, but Eugene also had to deal with his whole suit heating up that day. Inside the spacesuit, he felt like he was in a hot bath. High temperatures and hard work caused overexertion, dehydration, and severe weight loss. His face was sweating, and drops of sweat blinded him. During this spacewalk, the astronaut lost about 13 pounds of weight. Other astronauts came to the rescue and took him back to his spacecraft. To reduce overheating, they sprayed him with cold water from a hose. In a sense, to go out into an infinitely huge open space, an astronaut must put on a suit resembling a body cage. Another dangerous incident happened in 1973. Two astronauts, Pete Conrad and Joe Kerwin, went into outer space to repair a solar wing on the Skylab space station. The wing didn't turn around, and the astronauts tried moving it manually. Using force, they turned the stuck wing, but it pushed them. The push was so strong that it threw both astronauts aside. They didn't have time to grab onto a nearby surface and began to fly away into outer space. Fortunately, they had safety cables that didn't let the astronauts go away for good. By grasping them, the astronauts returned to safety. In an ordinary modern spacesuit, there are more than 10 protective layers. Such a suit protects against extreme cold and hot temperatures. It's tear-resistant and doesn't leak moisture from the outside. This protection is necessary to prevent depressurization. If a small passage appears between your body and space, then all the oxygen will start coming out of the spacesuit. The more oxygen the suit loses, the more vacuum it gets. This leads to terrible consequences, such as suffocation and increased body volume. It looks as if you start to inflate from the inside. In 2007, Rick Mastracchio went into outer space to do some repair work. For some reason, there was a hole in his left glove next to his thumb. It was on the outer layer of the glove. But the worst thing was that the astronaut hadn't noticed it. He continued to work as if nothing had happened. But one damaged layer could destroy the second. The second one could tear the third one, and so on, until the vacuum reached the astronaut's skin. Rick was supposed to work 6 hours in outer space, but during the 4th hour, he noticed the damage in his spacesuit. The astronaut reported this to command and received an urgent order to return to the ship. He never found out how the hole had appeared. Inside the ISS, there are many chemicals necessary for working in space. For example, ammonia has the property of freezing almost any surface. This chemical frost is used to cool some components of the station during overheating. The leakage of this substance on the ISS is practically impossible. This is exactly what astronaut Robert Curbeam heard from experts during the training before his first flight to space. But this accident occurred to him on his first spacewalk in 2001. Robert was working outside the space station when an ammonia leak started. The liquid splattered all over his spacesuit. A thick layer of ice quickly covered the glass. Robert didn't see anything. He feared that he had broken something, but the accident was not his fault. The protective layers of the spacesuit didn't allow Robert to freeze, but the ammonia severely restricted his movements. The main problem was that he couldn't return to the ship. Ammonia could get into the station, and this could lead to an emergency. Robert had to stand in outer space for 1.5 hours and wait for the leak to end. After that, he successfully returned to the station. To realize how difficult work is in outer space, we need to understand what a spacesuit is. It weighs 280 pounds, which is as much as a scooter. You won't feel its weight in zero gravity, but it will still make you sweat. Astronaut Chris Hadfield had described it by saying that every movement inside your spacesuit meets resistance. The suit scratches your skin, squeezes your bones and joints, and forces you to spend twice as much energy on simple movements. In such conditions, you start sweating and your eyes get wet. This moisture flies inside the helmet and blinds you until it evaporates. But if there's too much moisture, it can threaten the life of an astronaut. Such a case happened in 2013 with astronaut Luca Parmitano. He went into space to measure something outside the station. At one point, he felt that the back of his head was wet. He informed the others about it and got an order to return to the station. When Luca was coming back, he had to turn upside down. As soon as he did this, water gushed into his helmet. It covered most of his face. Luca couldn't see or hear. He tried to report the trouble to base, but the water covered his mouth. Fortunately, his partners rescued him and helped him return to the station. When they opened the helmet, almost half a gallon of water poured out. Astronauts' cables are some of the most reliable defenses against floating away into space. But what if one broke from a strong push, or because the astronaut didn't fix it well? For additional protection, there's a backpack called SAFER, Simplified Aid for EVA Rescue. It's like a jetpack. It releases gas from small tubes and changes the direction of your flight. If you're spinning in space, SAFER stops and aligns your movements. You can take manual control and fly using a special joystick. SAFER was first used in 1994, but before engineers created it, there was the MMU, the Manned Maneuvering Unit. In 1984, astronaut Bruce McCandless used it for the first time. You may have seen this famous photo where he floats in outer space without a cable. The problem was that Bruce was the first tester of such a jetpack. He wasn't 100% sure if it would work. He went into outer space and unhooked the cable from himself. There was nothing else to keep him from flying into the infinite black abyss, and his team wouldn't be able to save him. Imagine how scary it must have been. Fortunately, the jetpack worked. However, after 3 missions, NASA decided to stop using the MMU as it was unsafe. After that, engineers invented safer. Jetpacks and cables are reliable safety systems, but the best protection for an astronaut in space is their skills. Each astronaut has 6 years of higher education and several more years of training. They spend many hours training in virtual reality with spacewalk simulations. They train their body, endurance, and mind, since the main thing in a dangerous situation in space is not to panic and stay calm.
Space travel has come a long way since Sputnik was launched into orbit in 1957. Since then, we've sent humans to the moon, set up the International Space Station, and even sent robot spacecrafts to explore other planets. But there's still lots more to discover and achieve in space. So, what are our current plans? What technologies are we developing now? And what awaits humanity in the next 100 years? Let's find out, shall we? First of all, artificial intelligence. Fun fact, my high school history teacher claimed this is what I had as per my test scores. Right now, humanity is actively engaged in the development of artificial intelligence, and we've already made a bunch of breakthroughs in this area. With the help of AI, we're going to be able to explore the cosmos like never before. Think about it. AI can automate and optimize tasks like mission planning and data analysis. Now, human astronauts can focus on more important things, like looking for some non-human astronauts. Plus, AI can control and operate spacecraft remotely, reducing the need for risky human missions. And that's not all. This super smart technology can also provide unique perspectives and insights that humans might have missed. AI could also help us understand the data collected by space probes. In short, the use of AI in space exploration will help us learn more about the cosmos and make exploration more efficient and cost-effective. And this isn't the only thing that will help us in conquering space. Next, reusable rockets. Gone are the days of one-time use rockets. These days, reusable rockets are taking over the space industry. Not only do they save money, but they also make space travel more accessible to a wider range of people and organizations. To date, the SpaceX company has created a bunch of reusable rockets, like the Falcon 9 and Falcon Heavy. They've completed many successful missions to the International Space Station and beyond. Blue Origin has also made great progress in reusable rocket technology with the New Shepard. It's even planning to take paying customers on trips to space soon. Alright, so these cool technologies will help us get up there. But what are we going to do next? Moving on to building settlements beyond Earth. Space colonization, here we come. The possibility of establishing colonies on other planets, such as Mars, is a dream that has captivated humans for decades, and now it's finally within reach. But before we start packing our bags, here are a few obstacles we need to overcome. For starters, getting to Mars is no easy feat. It's a long journey that could take months, if not years. So first, we need to figure out how to keep humans alive and healthy during the trip. Now, once we get there, we'll face even more challenges. The harsh radiation and extreme temperature fluctuations are just a couple examples. Living and working in space isn't easy either. We need to make sure that everyone has what they need to survive. It's not like you can just go to the store for supplies. So we'll have to build systems to provide food and water, create some advanced transportation, and maintain all of that in good condition somehow. Finally, let's not forget about the most important thing: money. Building and maintaining a settlement beyond Earth is no small feat, and it will take a lot of resources and cooperation to make it happen. But there are still great benefits in living in space. It opens up many opportunities for scientific research and exploration. We'll be able to learn more about the universe and our place in it. So, no dream too big. Even though it's a big challenge, it has the potential to be really rewarding for humanity. That's why private companies and space agencies are already working on plans to send humans to Mars and potentially even terraform the planet. Actually, let's talk about that. Terraforming, the dream of turning a barren, inhospitable planet into a habitable paradise. Sounds like something straight out of a sci-fi novel, right? Well, believe it or not, by using advanced technology and resources, we could potentially turn deserts like Mars into beautiful Earth-like worlds. But here we also have a few hurdles to jump through first. Terraforming isn't exactly a quick process. It would take lots of time and resources to make any significant changes to a planet. There are also some ethical dilemmas to think about. If we start trying to change the Martian ecosystem, we could potentially wipe out any existing life forms. Imagine if someone did that to us. Actually, we've been doing it to ourselves. And finally, there's the cost. Terraforming would be a major expense, and it's not clear who would foot the bill. It would likely require the cooperation of multiple countries and organizations. But even with all these challenges, this is still an exciting prospect. Who knows? Maybe one day we'll be able to turn Mars into the ultimate vacation spot. And that's just the beginning, because we won't stop at Mars. Our next goal is asteroids and other celestial bodies. Now picture this, you're floating in your spacesuit, mining an asteroid for some seriously valuable resources. You strike gold, or rather a shiny vein of platinum, and head back to Earth to sell it for a fortune. And with the money, you fund even more space mining expeditions, becoming the ultimate space tycoon. But seriously, space mining could be a game changer for space exploration and the economy. Imagine being able to extract water from asteroids to sustain human settlements on other planets, or mining rare minerals to use in high-tech industries back on Earth. The economic benefits could be massive. Of course, there are also challenges to overcome. We'll need to figure out how to safely and sustainably extract resources from asteroids. We also need to make sure that space mining is done in an ethical and fair way. But once we deal with all this, it'll change our lives forever. So let's get to work. But once we've mined everything, what awaits us next? For example, what lies beyond our solar system? Interstellar travel and the search for life. We've already made some amazing discoveries in our hunt for extraterrestrial life. For example, NASA's Viking landers and the Galileo spacecraft have given us some clues about it. Also, in 2022, we found traces of organic matter in the former Martian lakes. We're not sure yet, but perhaps Mars was once as prosperous as Earth. But we all know that the real excitement lies beyond our solar system. Scientists have already found thousands of other distant exoplanets, and some of them are in their star's habitable zone, meaning they could potentially support life. So our next step is to send probes or even humans there. Imagine being the first person to set foot on another planet, discovering microbial life, or maybe even a more advanced civilization. Talk about out of this world. And maybe, one day, traveling to another star system will be like a regular road trip, except instead of a minivan, you're in a spaceship. And instead of stopping at a rest stop, you're stopping at a new planet. Sounds awesome, doesn't it? Right now, there are a few ideas about how we might make interstellar travel a reality. One possibility is the use of wormholes. These hypothetical tunnels in space-time could potentially allow us to travel vast distances in a shorter amount of time. It's like taking a shortcut, except instead of cutting through someone's backyard, you're cutting through the fabric of the universe. Pretty crazy, huh? Another option is antimatter propulsion. This involves using antimatter, which is the opposite charge of our regular matter, as fuel for a spacecraft. When it comes into contact with regular matter, it releases a huge amount of energy. Imagine your car's gas tank being filled with antimatter instead of gasoline. That's going to be a powerful ride for sure. Of course, there are still lots of challenges to overcome before we can make interstellar travel a reality. But let's hope that one day we'll all be able to pack our bags and hop on a spaceship for a trip to the stars. Anyway, the future of space travel is looking bright. With all of these advancements in technology, we're excited to see what feats of exploration the future holds. No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase, and it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean there are no sounds in space. In fact, there are plenty of them, and some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules. And that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of a vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sound somehow. So how do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them. And that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other, stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nasties, like radiation and solar winds. At the same time, we can neither see it, feel it, nor hear. Oops. Well, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA swarm satellite. They converted them into an audio track and got a pretty creepy result. Now, to be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of Earth's magnetic field, it starts to feel like a spider crawling nearby. Ew. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise, so much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars, or neutron stars. One time, Nikola Tesla caught something similar, but unfortunately, at that time, we didn't know about such things as pulsars, so Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the Moon, the side that we never see because the Moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But according to NASA, it's not some creepy extraterrestrial music at all. These may just be some radio waves that affected each other because of their proximity, although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. Now, 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user. So these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth, never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kind of sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave and a rock. But here, in terms of horror, Jupiter surprisingly loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting too. More like popping corn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space. And then, while abandoning its home, Voyager 1 detected the sound of plasma waves. The original recording lasted 7 months, but fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into soundtracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Now, those were the scariest space sounds captured by NASA. To be fair, most of them sounded creepy simply because they're radio waves, but it's still fun to get spooked sometimes. Now, did you know that there's an astronomical object in which space and time actually swap places? How does that work? And what exactly does swapping space and time mean? Well, let's figure it out. Imagine that you're on a spacecraft. The vehicle can only move straight. Your path leads to some inevitable point, and you have no idea what lies ahead. You can only hope that it won't be too bad. Meanwhile, everything around you is complete madness. A chaotic collage of many historical events. What do you see? Ancient humans and dinosaurs? The birth of the universe? Future? Who knows? That's what the universe would look like if we swapped time and space. And theoretically, this is what you would see if you fell into a black hole and somehow were able to survive. But how is something like this even possible? First of all, let's discuss time and space. Imagine drawing a light bulb on a sheet of paper. Then grab one more sheet and draw how it lit up. Right now, it's just a small circle of light. Another sheet, the circle of light is growing. It gets bigger and bigger in size until finally it turns into a giant circle. In real life, The bulb lights up in the blink of an eye. That's because the speed of light is the fastest in the universe. But here, on our drawings, we captured the propagation of light frame by frame. We see how over time the light has grown from a small dot to a large circle. But if you connect these circles, doesn't it remind you of some shape? For example, a cone? Yes, exactly. This is called a light cone, and time is the central axis of this cone. Why? Because light turns from a small dot into a large circle over time. To remember it, let's draw a time vector, an arrow inside the cone. It goes from the past to the future. Meanwhile, the circles are space. In space, we can move however we want, in any direction. We can move up or down, in zigzags, and so on. But no matter what zigzags we draw along the timeline, we're always moving forward. We can't turn back in time, and we can't stop it. This helps us define time and space. Time is the direction in which the light cone is oriented. This is the direction where all our paths lead, and where our future inevitably lies. And space is the whole variety of directions perpendicular to the timeline. This is a straightforward graph. If it could be applied to the entire universe, then time would flow the same everywhere. However, if you've watched at least some popular sci-fi movies, you know that this isn't the case. In reality, time can be crazy. For example, if you're chilling near a black hole, what will be 2 hours for you may turn out to be 20 years for your friend on Earth. But why? Well, take a deep breath. Now, gravity comes into play. Oh, I know about gravity. It's that thing that helps me to stand on the ground, you may think. But it's much, much more complicated than that. Gravity is one of the basic physical forces in our world, and it's incredibly powerful. In fact, she's such a girl boss that she can distort space and time. She can literally influence the speed of time like an almighty wizard. How? Well, let's take something slightly bigger than a light bulb. For example, a supernova. Somewhere in the universe, a star has just made a boom. How do we know about it? Well, nothing in the universe, no sound, no radio waves, nothing, travels faster than light. So we'll know about the birth of a supernova only when we see it. And this will happen only when its light cone grows enough and reaches our planet. So the light cone grows and grows. So far, everything is fine. And finally, it reaches our planet. But there's a catch. You see, our planet is very massive, and it has pretty strong gravity. What happens then? Gravity changes the direction of the light cone. It begins to attract the cone to the center of our planet, and with it, it also attracts our arrow of time. That means it slows the time down, and the closer the light cone is to us, the more the arrow bends and the slower time goes. What does it mean? Well, for example, the fact that the watch on your ankle will lag behind the watch on your wrist, that your head is aging faster than your legs, and that astronauts in Earth's orbit age a little slower than people on Earth. This is what scientists call general relativity. Right. But how does this relate to our topic? How can we understand what will happen if we swap space and time? Don't worry, we're almost there. Now, imagine a cosmic body with incredibly strong gravity. It bends time and space so much that it feels like they swap. This is a black hole. A black hole attracts absolutely everything to its center. No stars, planets, no light can escape from there. Let's say our light cone is approaching it. First, as usual, time begins to bend toward the center of the black hole, attracted by its gravity. But the gravity is very strong, so it bends more and more, and time goes slower and slower the closer you're to the center. In the end, the light cone crosses the boundary of the black hole, the so-called event horizon. At this point, it gets so distorted that now it's literally pointing downwards. We can say that time has changed its direction. Time is pointing downwards. What kind of nonsense is that, you may ask? It'll be easier to explain in a real example. Imagine you're a crazy astronaut who decided to jump into a black hole, and there's an observer in the spaceship who watches you doing this for some reason. At first, for you, nothing changes. You look at your watch, you see that 5 minutes have passed, and everything's okay. But for the observer, First of all, you'll fall for a very long time. The observer has been sitting there for 50 years, and you're still falling, all because your time has slowed down. Secondly, since space is also distorted near the black hole, the observer will see how you'll begin to stretch like spaghetti. This is a scientific term, by the way. It's called spaghettification. And then you finally cross the event horizon. The observer doesn't see you anymore. Light cannot escape from a black hole, so your image won't reach the observer even if you're still inside. And what about you? What if you somehow survived? Remember, the time arrow is pointing to the center of the black hole. What does it mean? It means that now, the center of the black hole is your future. It isn't a place, it's a fate that you can't change. And wherever you came from, as well as the rest of the universe, no longer exists for you. Because now, it's not a place, but an event from the past. And since you can't turn back time, you'll never be able to come back. But what is around you? Complete chaos. The rays of light now move in all directions, forward, backward, and so on. The rays depicting the events of the past, the future, the present, all this is moving around you. In reality, space and time didn't swap places, but it feels like they did. Because in space, you can now only move forward, as if along a straight line. And time, reflected in the light rays, surrounds you everywhere and moves in all possible directions. And here we go back to the beginning. This horrifying example helps us imagine what it would feel like if time and space got reversed. Of course, all this is just theories and guesses. The very idea that we're moving in some one direction, the one we haven't chosen, and there's complete time chaos around, sounds quite frightening. And yet, it would be a very interesting experience. Sounds dangerous. Why don't you go first? Alrighty then, are you ready to test your knowledge of the universe? We've got 40 questions for you. Let's see how long you can last. Now, let's get going with the easy level. Can you guess the celestial body from this photo? With those famous rings? Of course it's Saturn. What force keeps us grounded on Earth? Magnetism, gravity, or friction? It's gravity, the same force that put an apple on Newton's smart head. The Moon is an asteroid, a satellite, or a planet. The Moon is a natural satellite of Earth. Which star is closest to our planet? The North Star, Alpha Centauri, or the Sun? Well, it would be weird if it wasn't the Sun. Pluto is a dwarf planet. Is this true or false? The answer is true. Poor Pluto got kicked out of the main planet sequence, but joined its own family of dwarf planets in our solar system. What is the largest planet in our solar system? Jupiter, Pluto, or Earth? It's Jupiter, the gas giant. What planet is known as the red planet? Venus, Mars, or Jupiter? It's Mars. NASA's Curiosity rover showed us all its awesome red-orange desserts. Wait a minute, I mean deserts. My bad. The Sun is a planet, a comet, or a star. The Sun is a star, which was kind of spoiled in question 4. What event marks the beginning of the universe according to science? The Great Fission, the Big Bang, or the Huge Boom? Yeah, the answer is the Big Bang, hence the name Big Bang Theory. Black holes exist. True or false? The answer is true. We weren't sure before, but now we have even 2 photos of them. How many did you get? Write in the comments. Now let's move to the medium level. Guess the name of this scientist. This is a portrait of Albert Einstein. What can we call a group of stars forming a recognizable pattern? A galaxy, constellation, or a nebula? It's a constellation. Although, to be fair, galaxies and nebulas are also full of stars in different patterns. What is this phenomenon called? A lightning bolt, a shooting star, or an aurora borealis? This is a shooting star. Hey, make a wish. What is the smallest planet in our solar system? Venus, Mercury, or Mars? The answer is Mercury. Remember that Pluto is a dwarf planet. How many planets are in our solar system? Give yourself some time to count. We have 8 major planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Who was the first person to walk on the moon? Jeff Bezos, Neil Armstrong, or Elon Musk? Neil Armstrong. He's the only astronaut on the list. What is the name of our galaxy? The Milky Way, the Andromeda Galaxy, or the Steel Way? The Milky Way, like the chocolate bar, and the Andromeda Galaxy is our nearest neighbor. Man has already walked on Mars. Is this true or false? The answer is false. Only robots have been on Mars, but NASA believes that the first human Mars mission will take place in the 2030s. Saturn is a gas planet, Earth-like planet, or dwarf planet. Saturn is a gas giant, just like Jupiter. They're the biggest planets in our solar system. The Earth rotates on its own axis. True or false? It's true. The Earth rotates while it revolves around the Sun, which is why we have days and nights. Well, that level was a bit tougher. Are you keeping up so far? Well, prepare for the hard level. What is this object called? This is actually a telescope, specifically the James Webb Telescope. It's based in space instead of on Earth. Which of these planets has the most moons? Saturn, the Earth, or Mars? While we have only one moon and Mars has 2, Saturn has 146 moons, all because of its huge size and crazy gravity. Which planet is the farthest from the Sun? Uranus, Neptune, or Jupiter? It's Neptune. We mentioned it when counting the number of planets. It was also in order. How long does it take for light from the Sun to reach Earth? 8 minutes, 24 hours, or a second? Now remember that light also travels at a certain speed. It's 8 minutes, 20 seconds. The speed of light is 186,000 miles per second. What is the hottest color for a star? Yellow, orange, or blue-white? The answer is, surprisingly, blue or blue-white. A bit counterintuitive, right? What is the true color of the sun? White, yellow, or red? The answer is white. This makes sense because we know that white light, which comes from the sun, breaks down in all the colors. So we only see the sun as yellow because the atmosphere filters some of them. Earth has the most volcanoes in our solar system. True or false? It's false. Venus is the one with most of the volcanoes. It's actually the most toxic and crazy planet in our solar system. What is the name of the galaxy closest to the Milky Way? If you watch the video carefully, you'll get this one. It's the Andromeda Galaxy. But while it's our closest neighbor, it's still 2.5 million light-years away. What is the coldest planet in our solar system? Uranus, Neptune, or Pluto? It's Uranus. Pluto's not a planet. And you think that it should be Neptune since it's farther away from the sun, and average temperatures on Neptune are colder, minus 330 degrees Fahrenheit. But the lowest number, about minus 371 degrees Fahrenheit, was recorded on Uranus. So this place can also be considered the coldest planet. Now, which planet has the most moons? Well, we mentioned this one before. It's Saturn, with an insane number of moons. Whew, pat yourself on the shoulder for that one. Finally, let's tackle the impossible level. Good luck! What's the maximum speed of light in a vacuum? 1,000,000 miles per second, 186,000 miles per second, or 42 miles per second? If you don't know, try to guess this one. It's 186,000 miles per second. And the distance that light covers in 1 year of traveling is called 1 light year. Now, on which planet can you jump the highest? The Earth, Venus, or Mercury? On Mercury! It's the smallest and lightest planet in our solar system, so the gravity there is very weak. What is the main component of the sun? Oxygen, hydrogen, or nitrogen? The answer is hydrogen. It's what makes up most stars, and it's the most common element in the entire universe. What is the approximate age of the universe? 3 billion years, 13.8 billion years, or 100 billion years? Well, it's 13.8 billion years. Meanwhile, our sun is about 4.6 billion years old. Hey, I wasn't around then. Guess the name of this guy. This is a portrait of Isaac Newton. What is the hottest planet in our solar system? Venus, Mercury, or Earth? Well, you might think it's Mercury because it's closest to the sun, but it's actually Venus. Like we said, it's the most toxic and volcanic planet we have around here. What type of star is the sun classified as? A red giant, a white dwarf, or yellow dwarf? Even though the sun's light is white, the sun is a yellow dwarf, one of the colder star types. There's a black hole in the center of most big galaxies. True or false? That's actually true. While they don't suck in the entire galaxy, supermassive black holes usually hang out in the centers. What phenomenon causes the northern lights? Earth's magnetic field, cosmic rays, or black holes? It's the Earth's magnetic field. When sun particles reach the Earth and interact with the atmosphere, they release bright energy, which causes beautiful colors in the sky. Time for some math. If the speed of light is 186,000 miles per second and it reaches the Earth in 8 minutes, what is the distance between Earth and the Sun? Bonus points for calculating this in your mind. It's about 93 million miles. Now, did you crack the impossible level? All right, let's see if you're smart enough to answer the final bonus question. If you were standing on the moon and the Earth was directly overhead in the lunar sky, how often would you see the Earth rise or set? Think about it. The answer is never. The moon is tidally locked to Earth, which means that we can always see its one side, while the other side is always hiding away from us. Ooh, maybe it's shy. So the Earth would stay nearly fixed in the lunar sky at all times. So, how many questions did you get? Write it down in the comments below. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends.